This video is going to be an overview for all the things that we have taken throughout semester 2 and those that are related to our midterm exam. Okay? Our first objective, we are going to introduce the divisors. So we have to list the divisors of a certain number. First of all, I'm going to list the divisors of 10. So the first question I ask myself is, can I find a pair of numbers that when I multiply them together, the product is 10? Well, actually there are 5 times 2 equals 10. Okay? So we can say that 5 and 2, both of them are divisors of 10. Are they only the two divisors of the 10? No, because there are also another two pair of numbers. When I multiply them together, the product is 10. They are 1 times 10. So till now, I have 5, 2, 1, and 10 are divisors of 10. So how I list them? The divisors of 10, I start always by 1 because you know that 1 is the divisor of all numbers. So 1 times 10 is 10. 2 times 5 is 10. So the divisors of 10 are 1, 2, 5, and 10. So now I'm going to list another divisors. So first of all, let us just a quick conclusion. We can say that divisors are a pair of numbers that multiply together to give the target number I want to list its divisors. For example, let us see what are the divisors of 8. If you look at the both operations, 4 times 2 is 8 and 1 times 8 is 8. So what are the divisors of 8 till now? They are 4, 2, 1, and 8. So how can I list them? Divisors of 8 are 1, 2, 4, and 8. So 1 times 8 is 8, 2 times 4 is 8. Together we are going to solve this. If I have 24 and 36 and I want to list the common divisors between them, the first thing I have to do is first to list the divisors of 24. I always start by 1. 1 times 24 is 24. Now, is 24 divisible by 2? Yes, because I have 4 in the ones. So 2 times something, I know that 2 times something is 24, so it's 2 times 12. Now, is it divisible by 3? Yes, 3 times 8. Now 4, yes, 4 times 6. Is 24 divisible by 5? No, so those are the divisors of 24. Now I need to list the divisors of 36. I start by 1. 1 times 36 is 36. Is it divisible by 2? Yes, it's 2 times 18. Is it divisible by 3? Yes, it's 3 times 12. Is it divisible by 4? It's 4 times 9. Is it divisible by 5? It's not. It is divisible by 6. 6 times 6 is 36, so I just write the 6 only one time. Now I look at both of them. Okay? I have 1 in both, 2 in both, also 3, 4, 6, and 12. So what can I say? The common divisors of 24 and 36 are 1, 2, 3, 4, 6, and 12. Okay? Now we are going to talk about our second chapter, which is the decimals. Let us look at this place value chart. If you see, I have here a decimal point. Okay? Everything to the left of the decimal point, we call it the whole part. So this is, we call it the whole part because it expresses the whole thing. while everything to the right, we call it the decimal part because it's actually the part of the whole part thing. Well, if you look at the place of every digit, everything to the left start by ones, tens, hundreds, thousands, 10,000s, while everything to the right start by tens, hundreds, thousands, and 10,000s. Always remember, decimals have a th at the end of their names just to differentiate between the decimal part and the whole part. For example, if I asked you that 7 is in what place, if you told me that it's in the hundreds, it will make conflict. That's why we say that 7 it's in the hundreds. Okay? But now, how can I read a certain decimal number? We will take, for example, 20.045. How can I say it in word form? The first step, if you look, you read the whole number part. What do I have in the whole number part? I have 20. So it's written 20. Instead of the decimal point, so every time you see a decimal point, you say and. So here I have and. Now you read the decimal part as it is. For example, here what do I have? I have 45. But don't forget to say the place value where the last number is. The last number is in the thousands. So I follow the thousands after 45. Okay, so for example, okay, I need to tell you something is very important, that every zero to the right of the number in the decimal part, it's useless. We call them extra zeros or useless zero because they don't change actually the value, but they change how you pronounce the number. That's it. So if you look at this number 0.2, here I have 0.20, 0.200, but if you want to say it in as a value, it's actually 0.2 because those zeros are useless. I can remove them. Let us try by ourselves. I have here the word form and I'm going to write it in standard form or in digits. The first one is solved. I'm going to give you a way to pay attention, to always have a correct answer. Always circle the and. Why would you circle the and? Because it separates the whole part from the decimal part. And don't forget to underline the place of the last digit. For example, what do I have here in the whole part? I only have 40, so I write 40. Instead of the and, it's point. I have 2, but I have 2 in the thousands. So how many digits? 3. 2 only in the thousand, that means the tenths and the hundreds are zeros. Let us continue. Don't forget to circle the and, underline the place value of the last digit. 12 in the whole part and 12 hundredths. I have hundreds, that means I have two numbers. I have 12, so 1 in the tenths and 2 in the hundredths. Also circle the and, underline the place value. I have 80 and 80 10,000s. That means I have 4 digits and I have 80. So what do? Like this, and the zeros and the tens and the hundreds. Now I have numbers and I need to write them in word form. I read the whole part, so I have 9. Instead of the point, I'm gonna write and read the decimal part as it is. I only have 4, but this 4 is in the hundredths place. Let us continue. I have 20. I can remove this 0 because actually it's useless. And I read the number 20 and 4 hundredths. I continue. It's 100 and 1 hundredths. Okay, let us look at this exercise. Which one of them is true? Is 2.01 is equal to 2.010? Yes, because this 0 is useless, so they are equal. But those are not equal because the one here is in the thousands, while here it's in the tens, so they are not equal. This is equal because I can add zeros as much as I want. This is not equal because I can't add zeros between the digits. I have here 2 and 1. I can't add zeros in between. I can add only zeros after the 1. Those are equal and these are equal. Okay? Now, how can I convert a fraction into decimal? Look, if you look at this fraction, I have 567 divided by 1000. That means if I have in the denominator 1000, that means I have 3 digits in the decimal part. What are these digits? They are 7, 6, 5. So it's 0.567. Okay, so if I have in the denominator 10, that means I have only one digit in the decimal part, which is in the tenths place. 2 zeros, hundredths. 3 zeros, thousands. Now I have 4 over 1000. That means I have only, well, first I have 3 digits in the decimal part. And the only number I have is 4. It's in the thousands place, which is here. So the rest are zeros. So the number is 0.004. Now look at this number. I have 2 over 10. So I have only one digit in the decimal part, in the tenths actually, which is 2. So it's 0.2. Now we are going to learn the steps of rounding a decimal number. Well, it's we have the steps similar to that of a number, a usual number. Do you still remember our song? Find the number, circle it. Look next door, 4 or less, just ignore, 5 or more, add 1 more. So, I have the decimal number 5.328 and I need to round it to the nearest hundreds. So what do I have in the hundreds? I have 2. So I look just before 2, I have 8. 8 is 5 or more. So I add 1 to the 2, it becomes 5.33. Everything to the right becomes 0, but you know that this 0 is useless, so I can remove it. So we obtain 5.33. Now we are going to learn how to compare two decimal numbers. If you look at those two numbers, Sarah and Danny, I need to compare their score. The first thing I do is to look at the whole part. I circle the whole part. What do I have here? I have here 42 and here 42. That means I have the same whole part. If you have the same whole part, you go for the decimal part and you start comparing it digit by digit. Here I have 1 and here I have 5. 5 is greater than 1. That means that 42.5 is greater than 42.1. Let us compare all the following numbers. Circle the whole part. Which one is the greatest? Jacob, which is 46.1. So directly I write 46.1 is greater than. After the 46 I have 42, but actually I have three numbers that they have 42 as a whole part. So I compare the decimal part. So we see that 42.5 is greater than 42.1, which is greater than 42.0, and the last one is 40.7. So the steps are, you start comparing the whole part. After you compare the whole part, if they are the same, you start comparing the decimal part digit by digit. Okay? Now we are going to talk about the third thing for our midterm exam. It's about fractions. First of all, you have to know that a fraction is composed of a numerator and a denominator. For example, if you look at this figure, I have one colored box out of two. So the colored thing or the part of the thing is the numerator and the whole thing is the denominator. So the numerator tell us how many parts are there I need, for example, in a certain figure. Okay, if you look at this shape, how many uh, colored equal parts in this shape? I have 3 out of 4. So the numerator, as we said, tell us the part of the whole thing, which is the denominator. Let us practice some of them. So here I have 3 colored boxes out of 4. Here I have 2 colored boxes out of 3. Here I have 1 over 8 and 5 over 8. Okay? Now we will talk about something called fraction of a number. So what's, for example, 1 over 5 of 30? We are going to, for example, if you have this figure, I have actually 6 cupcakes. I need to know 1/2 of the 6 cupcakes. I can't actually know unless I decompose those cupcakes into 2 groups. So as you see, I divided the cupcakes into 2 groups, and 1 over 2 of those 6 cupcakes it's actually 3. So one group of 2 groups are 3 cupcakes. So now let us calculate. As a calculation, if I don't have figure, how do I solve it? You have to know first that every time you see of, it's times 30. Now you multiply the numerators, you got 30 divided by 5, it's 6. So 1/5 of 30 is 6. What if, for example, you have 2 over 10 of 40? What do you do in this case? It's better for you to keep the 2 alone. You change this denominator to the 40, so you will get 40 over 10. Now 2 times, what's 40 over 10? It's 4. So 2 times 4 is 8. Now we are going to talk about equivalent fractions. If you look at this whole part in yellow, I divided this whole part into 3 parts. So every part is 1 over 3 of the whole part. Then the 1 over 3, I divided it into 2 parts. Every part, 2 equal parts, it's 1 over 6. So we can say that 1 over 3, which is in the blue, is equal to 2 parts of 6. 2 orange part. How did the 1 over 3 became 2 over 6? If you look at the numerators, what did I do? Times 2. Now, the denominators, 3 times 2 is 6. So I have here the same operations and the numbers are correct. So yes, those two numbers, we call them equivalent fractions. Why we call them equivalent fractions? Because they express the same amount. So if you look at both of them, they express the same parts. But this is 1 over 3 and those 2 parts, each of them is 1 over 6. Also here, 2 over 6 is equal to 1, 2, 3, 4, 4 parts out of 12. So I then divided them. So we can say that 1 over 3 is equal to 2 over 6 is equal to 4 over 12. Those we call them equivalent fractions. If you look at this, for example, if we have 4 over 12, I need to find an equivalent fraction. I can multiply it by any number I want. So let us multiply, for example, by 3. What do I get? 12 over 36. And so on. So every time you multiply by a number, you should make sure that you multiply the numerator and the denominator by the same number. So then we will obtain 2 equivalent fractions. Not only multiplication, I can also divide. So for example, if I have 8 over 12 and 4 over 6. How did the 8 become 4? It's divide 2. 12 divide 2 is 6. So yes, those are equivalent fractions. Let us practice some examples. Suppose I have 2 over 3 and I ask you to find 3 equivalent fractions. Don't forget that you have to apply the same operation on both terms, the numerator and the denominator. Suppose I want to multiply by 4. 2 times 4 is 8 over 12. I can now multiply by 10. What do I get? 180, no, sorry, it's 80, over 120. Now I can multiply by 2. I get 160 over 240. So I can multiply by any number I want, but the only condition is that you have to multiply the numerator and the denominators by the same number. Suppose I have 50 over 75, and I asked you to find two equivalent fractions, but you have to divide. I can divide both terms, for example, by 5. Okay, what do I got? 10 over 15, right? Now I can divide again by 5, so I got 2 over 3. Okay, so you can apply multiplication, division, but the only condition, the same operation, the numerator and the denominator. The last thing I'm going to talk about is that how you find common denominator of two unlike fractions. Suppose I have 1 over 3 and 1 over or 2 over 4. Do they have the same denominator? No. How can I make them the same denominator? The first thing is that you multiply the first fraction by the second denominator, which is 4. Then you multiply the second fraction by the first denominator, which is 3. What do you get? 4 over 12, 6 over 12. So I have now the same denominator. Another example, 3 over 2 or 3 over 7 and 1 over 5. What do I multiply? The first fraction by the second denominator and the second fraction by the first denominator. So it's 15 over 35 and 7 over 35. Okay, that's what we call common denominator. Okay.